All right. Well, welcome back. I hope everyone's had a good holiday. Now, this is going to be the first lesson of the advanced style content. So we're actually pretty much going to continue on from where we left off with graphing stuff, but rather than starting with graphing, let's dive a little bit further into some of the algebra and some of the behind the scenes work of polynomials. So I hope that people remember, but a polynomial is essentially just it's either an expression, like an algebraic expression, so I don't know, like y equals x squared or x squared plus 5 or something like that. That's a polynomial, or x squared plus x plus 1, something like that, something that's got an x squared, an x, and a 1. Now that's a quadratic polynomial because the degree is 2, and we'll get into all these words in a sec, but that's a special type of polynomial. There's heaps of polynomials. So it's either an expression or it can be a graph or an equation being y equals something. We're actually going to move away from y equals, and that's going to get kind of interesting. Or you might just have a graph and it looks something like that. That's a polynomial, whereas something like this is not a polynomial. So I hope that the word polynomial isn't something that's new. It should be something we've definitely seen before. And I've just written here that it's an algebraic expression that involves powers of x. So like y equals x squared, y equals x cubed. They're all polynomials. That's just a straight line. That's a parabola, and that's a cubic. They have different names, but it's a linear polynomial, a quadratic polynomial, a cubic polynomial. They're all polynomials. They're just different types. So the other thing to note is that the powers of x, are positive integers. So I've got y equals x to the power of 2 or 3 or 4. I don't have to the power of minus 1. If I had that, there's a different way of writing it. It's 1 on x, okay? So these two are the same thing. So if I've got a negative power, then it's not actually a polynomial, and we should know what this is. That's actually a hyperbola, which isn't a polynomial. So just note that a polynomial has to have positive integers as powers on top of the x. That's all that means. Okay, so I really hope people find this topic interesting because, again, it's just backing off the last topic, and it's really prominent in both Advanced and Extension 1. So if you don't like polynomials and you've chosen those two courses, then sucks to be you, because pretty much half of both of those courses are polynomials. So let's jump straight into it. I've just written what a polynomial is. It's just an algebraic expression involving powers of x. Powers of x have to be positive integers, and most polynomials are going to look like this. So in general, or the general form, and you might have heard the term general form. Remember when we had y equals ax squared plus b, no, what's general form? It was ax plus by plus c equals 0, wasn't it? That was a general form of a straight line. Has nothing to do with the general form of this, but you know. Notice also that I forgot that. It's because the general form is a straight line. Who cares about it? I didn't even remember it just then. Okay, so a polynomial looks like this. Y equals. Now I said that it could have been, and actually let me go over the examples. So we've got a linear polynomial. I'm not going to write. Oh yeah, I will. It's a linear polynomial. So that looks like y equals something, we normally say mx plus c. So it's like x, and then the power of x is 1, and there's a constant on the end. And then we looked at quadratics, so quadratic polynomial, and that looks like y equals, and we said ax squared plus bx plus c. So you'll notice that the highest power is 2, but I could also have an x to the power of 1, and you know that's kind of like an x to the power of 0. So they kind of like decrease. Now a cubic, I don't know why I drew the dots there. Cubic, y equals, now we haven't looked too much into cubics. We've only really looked at like x cubed, and like moving it up and down and left and right and stuff like that. But if you were to expand all of that, it would be, you know, ax cubed plus bx. You have a squared term and a cx, and then plus d or something like that. So you can see that the higher my power is, the more terms I could possibly have. I don't want to make this video too long, but I think it's important to note what could happen. So then a quartic, you could have ax to the power of 4 plus bx to the power of 3 plus cx to the power of 2 plus dx plus e. You know, this is kind of looking weird. Something in my eye. So in general, what you might find is that obviously this can go on forever, and there's names for the ones that go on forever, I think. But essentially you could have ax to the power of n, so whatever n is, your highest power. Then your next power is going to be, I'll write b, so bx to the power of n minus 1, so we'll have 1 less. And then plus c, x to the power of n minus 2, plus blah, 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 all the way up to, and then you'll notice that there's always like a constant term on the end, so like a number that doesn't, or a letter that doesn't have a, like an x next to it. So plus blah, blah, blah. Oh no, I've already used c, so what am I going to use here? Z, like this is kind of weird. I guess another thing you can notice is, remember when we used to say mx plus b? That's kind of why, because I've got b, c, d, e. That's kind of why they did that, but then we changed it to c for zero reason. So anyway, now with my general form, it's a little bit counterintuitive because I'm saying that n could be anything, and this could be like as big as possible, and I've used a, b, c, and that's kind of like a finite set of alphabets, letters. So instead, what I'm going to do is, instead of using a, b, c, I'm going to use I'm going to use a n minus 1, a n minus 2, all the way up to a 0. Would that be my 0th term? Yeah, it would be. Okay, so I have my a term, or the nth a term, the n minus 1th a term, the n minus 2th second. And then here you'd have like a1x, you'd also have a2x squared. So you can see that it would like fill in the gaps. I don't want to dwell too much on that, the general form, but essentially polynomial is just a series of, or an expression that has a bunch of powers in it. That's it, that's all I want you to know. So where do we go from here? Well, there's a bunch of terms that I want to go over. We haven't really discussed some of these, but they're pretty obvious, some of them. And here they are. So my leading term, what does that mean? Well, the leading term you might think as the first term, and yeah, that's right. But what you'll notice in each of these expressions is that my first term is always the one with the highest power. That's not always the case. Like a question might give you y equals 1 plus x squared. My highest power is this term here. I'm not going to call this my leading term just because it's sitting in it's like the first thing left. You don't call this the leading term. You call the leading term the term with the highest power. So term with highest power. So for example, if I had y equals, I don't know, 2x to the power of 4 plus 3x to the power of 5, my leading term is 3x to the power of 5. That's it. So it's the thing with the highest power. The second thing is my leading coefficient. So the word coefficient I hope we've seen before. The coefficient of something is just the number that's next to a bit of algebra. So in our case, we're working with x's everywhere. So it's the coefficient, or the number next to the leading term. So it's the, I don't want to say coefficient because it's in the thing. So the number next to the leading term. The leading, yeah, we'll just go with term. So for example, we'll use the same example. So y equals 2x to the power of 4 plus 3x to the power of 5. The leading coefficient is 3. So my leading term is this, my leading coefficient is this. Okay, next thing is the word monic. We would have seen this before, and it's when we were factorizing, but monic just means it's a polynomial where the leading coefficient is 1. So the leading coefficient is 1. So for example, if I had y equals x squared plus 2x plus 3, you can see the leading term is this thing. The leading coefficient is that, the 1. So that's a monic polynomial. If it was non-monic, that would just mean like this. Whoops, that's my rubber. So if that was a 3, that would be non-monic. This thing's non-monic because that's a 3. This thing's also non-monic, it's the same thing. If A was 1 in each of these cases, they'd be non-monic. Okay, the constant term. So the constant term is just the thing that's on the end. So it's, what's the proper definition? Oh, it literally says at the end. Okay, term at end. Let's go with that. Term at end. There's another way of saying it. It's independent. It's independent with E, yeah, of X, which means that, let me just do an example. So the example, y equals x squared plus 2x plus 3. My constant term is the 3, so the value on the end, and it doesn't have an x into it, next to it. So it's independent of x, which means it's not affected by x. So like it's just a 3. In this example, there isn't a constant term because both terms here have an x in them. If you look here, all the constant terms here are these ones on the end, and this one here. Okay, and the last thing is my p of x notation, which we haven't seen yet. So I want you to, I don't want this video to be too long, already is great. So essentially what we have when we're looking at polynomials, don't think of the graph for a second, just think of the equation. So let's just go with, what one do we want to look at? Let's just, who cares? Let's just look at this thing. So pretend this is my equation. Let me write it actually. Let's just make up a new one. 3x squared plus 4x plus 2. Okay, this is a parabola. It's a quadratic polynomial. Now, what you can think of it as what we do is we put x values in as an input, and then the output is a y value. So what I mean by that is a lot of questions will be like, okay, here's your expression. Tell me what happens when x equals 2. Okay, so then when x equals 2, then I have y equals 3, 2, plus 4, 2, plus 2, and that's equal to 12 plus 8 is 20, so that's 22. Okay, so in other words, I put a 2 into here, and what happens? The output is 22. And if you think of the graph, I don't know what this thing looks like, it's a parabola, so it probably looks like this or something. When I figure out x equals 2, let's suppose x equals 2 is there, that's my input. What's my output? Well, my output's up here, which is 22. So if you think of an algebraic expression as an input and an output, or they're actually called functions, like a machine. So I guess if you put ingredients in, the output is what comes out after the ingredients do their thing in the machine. That's what this essentially is. I'm putting my ingredients in, my 2, I'm putting that into the machine. What comes out is my y value, my 22. So you can think of that as the input and that as the output. This is the last thing we're going to do, by the way, so I don't want to confuse people too much. Okay, so I've got an input and output. My input was 2, output was 22. So rather than saying x and y, what we instead say is, okay, I have a polynomial, p. Now this letter will change depending on what this is, but at the moment I'm just using a polynomial. Now my polynomial has x's inside of it. And I'm going to call that 3x squared plus 4x plus 2. So I'm defining this polynomial. It's a thing, it's a machine, it's a function, it's something, and then there's x's inside of it. So my x's are here. Now what I want to do is, instead of having x's inside of it, I want to put 2's in it. So what I'm going to do instead is I'm going to have a polynomial, and I'm going to put 2's into it. So when I do that, all I'm doing is thinking of this as like a placeholder. My x is here, my x is here, my x is here. Instead of having x's, now I'm going to have 2's. So I'm just going to have 3 times 2 squared plus 4 times 2 plus 2. And same thing, that's 22. So, is there anything I want to say about that? Not really, yes. Yeah, okay. So I guess you can say that this is just a polynomial using x. That's, I guess, what you think about that. Okay, so instead of thinking about these as expressions in graphs and stuff, we're going to start thinking about them as functions. So like a machine, so like what we just did here. Okay, a couple of questions. These won't be too hard. This video is going to be a bit longer because I'm introducing so many terms, but whatever. Determine which each of these represent a polynomial. So you'll see that they've switched up the notation. So instead of saying p of x, they're just calling this a. So it's the function a, or the polynomial a. They're just giving it a name because we're talking about a few different ones. So it's kind of like when we were graphing two things before, and we said y equals blah, blah, and then y equals blah, blah, and then we tried to graph them. And it's like, how do I distinguish between them? Because then when you graph the two of them like this, then you have to label them. So then I have to say y equals all this and y equals all this. Instead of that, we're moving towards having two graphs and just saying, okay, this one's a with x's, and this one's b of x's. That's what we're kind of moving towards. So we're naming things a little bit more efficiently, but also treating them as if they were machines. So for a of x, we just want to know whether it's a polynomial. So I guess you can think of it like, well, look, here's the leading term because it's got a power of 5. Now it's a bit of a trick question because this x squared, you've kind of got all these positive integer powers, but actually this is on the bottom of a fraction. So really you can rewrite this as, and it looks weird because there's this surd here, but just remember a surd's a number, so it doesn't really matter what it is. So that's root 2x4 minus 7x5 plus 3x to the minus 2. So there's a way of rewriting it to make sure that this isn't on the bottom of a fraction, and just simply by that I can determine that because that's a negative power, not a polynomial. In fact, it's also not a hyperbola because there's these terms. If this wasn't here, this is just a hyperbola, but because this is here, you can look up what the graph is. It'd probably be really strange. And the reason is because it's got a negative power. Okay, b of x is just, look, 5x plus 2. So that's just a straight line, so it's a linear polynomial. Okay, c of x. Now, I need to rewrite this because it's root x. So that's the same as 2x to the half. Hope people remember that. Plus x to the power of 3 plus 7. Okay, so that's also not a polynomial. This time not because it's negative, but because it's non-integer. So it's a fractional index, or fractional power. So they just need to be whole numbers and they need to be positive. And then d of x, I'm not using capitals anymore for some reason. Let's chuck a capital in there. So if you were to expand this and to get it into this general form, so general form just means that I have all my terms laid out beautifully. And don't get confused by these ANs and stuff. They're just numbers. Like this could be a 4 and a 3 and a 2. Who cares? But they just need to be laid out beautifully. That's the general form. This one's factorized, so it's not in general form. So that means I'll just quickly expand it using FOIL. So that's going to give me x cubed. That's going to give me 5x squared. That's going to give me minus 2x. And that's going to give me minus 10. Now it's in general form because all the terms are next to each other. And also they're in order. I've got the cubic term, the quadratic term, the linear term, and the constant term all next to each other. And I can say it's a polynomial. It's actually a cubic polynomial. And how do I know that? Because the highest power is 3. Is there any other words I need to go over? Yes, these ones. Okay, this is going to be a long video. Whoops. All right, for the polynomial, state the following things. A, B, C, D, E. Okay, the degree. So I haven't actually spoken about what the degree is, but the degree is just the highest power. So the highest power, have I skipped? I must have skipped that. So the degree is the highest power. So for this, the highest power you can see is 6. It's actually in order for us. So happy with that, degree is 6. The leading term is the term that has the highest power. So the term is 7x to the power of 6. So just the whole thing. The leading coefficient is just the number, so 7. D, the constant term, so the term on the end, minus 2. Don't forget the minus, so that's minus 2. And whether the polynomial is monic, it's not monic because the the leading term, so this thing, has a 7 in front of it. So it's non-monic. monic. If that there was a 1, you would say it's monic. Okay, last thing, let's start using our machines. So I've got, and I like to write them on top of each other. So P of x is 3x to the power of 4 minus 6x squared plus 4. P of 3 is just going to be 3 inserted where the x is. And that's going to be, off the top of my head, 193. P of minus 2, so this is just, be careful, use brackets. And we've been doing this for a long time. This is just like finding the x and y intercepts, but instead we put zeros in, right? That 4 doesn't even look like it's on the power, so let's just fix that. Plus 4, off the top of my head, that should be around 28. And then, okay, this last one, so that was A, B. This last one's C. P of 0, so remember, that is finding the y-intercept. Okay, so P of 0 minus P of minus 1. Okay, so P of 0 is going to be, let's just do these separately. P of 0 is going to be 3 times 0 minus 6 times 0 plus 4. That's 4. P of minus 1 is going to be 3 minus 1, 4 minus 6 minus 1 squared plus 4. That should just be 3 minus 6 is minus 3 plus 4 is 1. Okay, so then P of 0 minus P of 1 minus 1 is the same as 4 minus 1, which is 3. So there's a lot of new words, there's a lot of different notations for the same thing. There's a lot of terminology, there's a general form, but it's all different, which is why this is probably taking so long. The next lesson is pretty easy, so I just want people to get used to the different words, used to the different way of thinking about what a polynomial even is, and we're moving away from graphing for a little bit and just kind of focusing on I guess the roots of